students, good morning to all of you. In the last class we have discussed about the important terminologies of motion, that is speed, velocity, acceleration, what is distance, what is displacement, what is origin. But today we will discuss about the most important concept of the chapter motion, that is equations of motion, which is very important from your examination point of view. When we can derive the equations of motion. When an object is moving along a straight line with uniform acceleration, we can correlate its velocity, acceleration and distance covered in a given time interval from the following equations. The first equation of motion is known as the velocity-time relation, which is expressed by the symbol v is equal to u plus at. And the second equation of motion is distance-time relation, that is s is equal to ut plus half at square. And the third equation is distance-velocity relation, which is v square is equal to u square plus 2s. Now we will draw a diagram and derive all the equations step by step, one after another. Let us consider an object is moving in an uniform acceleration in a straight line. In that line, it starts moving from a point and reaches at another point in time t. Suppose in this diagram you can see clearly that an object is moving from point A to point this. Suppose this is E. And when that object is in this position, the initial velocity was u. And when the object is at this position, the final velocity is v. And the time taken to reach from here to here is time t. This is the time. So in time t, an object starts moving from this position A and reaches at this position E, and the initial velocity was u and the final velocity was v. If u is equal to initial velocity of the object, u the initial velocity, v is the final velocity of the object, t is the duration of time. The time taken from this position to this position is t, and a is the acceleration and s is the distance traveled in time t. Look at this graph. Here AO is equal to DC is equal to u. AO, this portion AO, we know that this portion is equal to initial velocity u. AO is equal to DC is equal to DC. This portion is equal to this portion. Though this is a rectangle, opposite sides are equal. So AO is equal to DC. This is also U. And EO is equal to BC. EO, this portion. This portion is EO. That means the final velocity. This is the initial velocity and this is the final velocity. So EO, this portion total is the final velocity, that is V. EO is equal to BC. EO is equal to BC, that is equal to V. This total portion is V. OC is equal to AD. OC, definitely OC. The time taken from position O to C, the time taken is T. So OC is equal to AD is equal to T. BD is equal to, what is BD? BD is equal to BC minus DC. Then what is BC? BC is the V and DC is U. So BD is equal to BC minus DC, that means V minus U. Now we derive the first equation, that is velocity time relation. We know that acceleration is equal to change in velocity by time taken. By definition, the definition of acceleration is change in velocity by time taken. What is the change in velocity in this graph? velocity changes, this velocity minus this velocity is the velocity change in velocity. So this velocity is v and this velocity is u by time taken. What is the time taken? Time taken is t. So a is equal to v minus u by t. By cross multiplication, v minus u is equal to a into t, at. So v is equal to, side changes from this side to this side. So u will be positive, u plus at. This is our first equation of motion. V is equal to u plus at. Then the second one. Now we'll derive the second equation of motion, that is distance time relation. We know that distance is equal to area under curve. Area under curve. What is the area under this curve? This area. That means area of the rectangle OADC plus area of the triangle ABD, that is equal to area of a rectangle OADC plus area of triangle ABD. That is equal to, what is the area of rectangle? Length into breadth. So here breadth is u, length is t. U into t plus, what is the area of triangle? Half base into height. What is the base here? Base here is t, because OC is equal to AD. OC is t, so AD is also t. So in place of AD we can write t, half base, half into t into height. What is height here? BD is the height. What is BD? You see BD? BD is equal to BC minus DC. BD is equal to BC minus DC, that is equal to V minus U. You can write here also OA into OC plus half AD into BD from the graph. Okay, that is equal to U into T, UT plus half into T. What is V minus U? From the first equation. What is first equation? V is equal to U plus AT. If we take U from this side to this side, it will be minus. So V minus U is equal to AT. So in place of V minus U, we can write AT. In place of V minus U, we can write here AT. That is equal to UT plus half AT square. T into T square. So S is equal to UT plus half AT square. Okay. So the second equation of motion is proved. Now we derive the third equation of motion, that is velocity distance relation. We know that distance S is equal to area under curve. Area under curve, that is equal to what we have taken in second equation, the area under curve, the area of this rectangle plus area of this triangle. But here we will take the area of this rectangle plus this triangle get together makes a trapezium. O, A, B, D, C is a trapezium. So here we will take area under curve is equal to area of trapezium, what? OA, B, D, C. OA, B, D, C, this whole area. What is the area of trapezium? Half into sum of parallel sides. Sum of parallel sides into h height. That is equal to half into what is the sum of parallel sides here? The parallel lines are AO by OA and BC. What is OA? That is equal to U into what is BC? BC is equal to B into what is height? What is height here? In this trapezium, this one is the height OC. What is OC? OC is T. That is equal to half into U into V. Sorry, U plus V. Sum of the parallel sides. U plus V into T. U plus V into T. In place of T, we can write from the first equation. What is the first equation? V is equal to U plus AT. So AT is equal to, this one is equal to V minus U. So T is equal to V minus U by A. Here in place of T, we can write V minus U by A. That is equal to half A plus B, A minus B, V plus U plus V. Sorry, V plus U, U plus V, we can write it also as V plus U, V plus U and V minus U, that is into A plus B, A minus B, A square minus B square by A. A is equal to half into V square minus U square by A. By cross multiplication, V square minus U square is equal to the half multiplied by V square minus U square by A. What will be? That is equal to V square minus U square by 2A. So A is equal to V square minus U square by 2A. So V square minus U square by cross multiplication will be 2AS. This was the required equation for us, the third equation of motion.